Hello, community. So great that you are back. You ask me, hey, when is the right time to start to code agents? What framework should I use? Which particular company implementation should I follow? When is the right time for agents? If I want to learn agents. Now, the answer is today. Today is the perfect time to learn how to code agents because we have a new agent development kit published today, April 9, 2025, by Google. Now, whenever you start, it is great, but I think today is really a very special time here because in the last month, everybody developed its own agent development kit. Every company had its own ideas. You have here your own very specific, model-specific implementation. But now I think Google developed something that is really across all the different models. And currently I use here Google LLMs here, the Gemini Pro 2.5 here. Really, I think this is for me my best model. So therefore I want here to have here an agent development kit that is optimized here for the best LLM that is currently on the market. So I don't know how to say this, show you here. I just read a manual. This is all I will do. I just have a look. What is it that they published? Because I have not been there. I have not been integrated here in the development. I have no idea. So this is my first look. It will be a catastrophe because I have no plan. I just put my nose in. So if you want to learn with me here about the latest development, how to build agent, today I think it's the perfect timing. So let's have a look. Why use Google? Introduce agent development kit, beautiful, multi-agent by design. This is what we want. A rich model ecosystem. Oh yeah, because we want to push it then if we have production on multiple continents on this beautiful planet. So we need scaling. We have a beautiful rich ecosystem. We can use pre-built tools like search. Google search is maybe a beautiful tool that you want to use here. We have here compatibility with MCP tools. You can integrate third-party libraries like LangChain, Llama Index, whatever, LangGraph or Crew.ai. You have streaming, you have flexible orchestration. It is an easy thing to learn and it can be damn complicated if you really have a deep dive into the coding. Let's have a look at this. Let's start and let's build our first agent here with this new agent developer kit. And here it is. So we say, hey, LLM agent. This is our agent. So what we need, you remember an agent, the core is here an LLM. So we need here Gemini 2.0 Flash, whatever, so you specify the LLM. You can go with Claude 3.7 or whatever you like. You give a name to the agent, a question answer agent, and then you give a description. Description is simply you say, hey, you should be a helpful assistant agent that can answer questions. And then you need to give here minimum an instruction so that you define, hey, this is your task. Respond to a user query using here Google search tool. And remember, tools are important here for our agents to interact with the environment. And we have a predefined tool, and you know what? It's called Google Search. That's it. This is your first agent that goes on the internet and searches here for you if you're looking for something specific. This is your agent definition. You have defined your LLM. You have defined the instruction, what this agent should do. And you have given the agent here a tool to interact with the environment. And for Google, it is a Google search tool. So this is something really beautiful. You might say, yeah, but I could add now a specific memory structure, a dynamic memory structure. I could use here state-specific updates. Yes, but we will come to this in a 2 minutes time. You can have the way you interact, your CLI, web UI, API server, API, whatever you have. It is now at a state where I think you can really work with this thing. So building multi-agent application, yes, beautiful. So you know this typical now. You want to define a tool, and the simplest tool we know is a weather tool. So we sign here, get weather. We have a city as a string. We build a dictionary. We say, tool get the weather called for the city, I don't know, let's say Toronto. You have your database. We have here this simple database. We just say It's partly cloudy in Toronto with a temperature of 30 degrees Celsius. This is it. And then we say if return here city normalized, so the temperature of, let's say, Toronto, else you say it's a error. So we have defined now here this get weather. Then we define here our agents. And let's define 3 agents. Yes, it is that simple. It is unbelievable. So here we have, of course, our root agent here, the mastermind, our agent. And we call it here the weather agent. What else? No? As an LLM, we use Gemini 2.0, use 2.5, whatever you want to pay for. And the description. The description now tells it here, hey, you are the main weather agent, coordinating now a team of other agents. And your main task is here to provide the weather using the get weather tool that we just coded here 5 seconds ago. Handle its status response, report here the temperature back or send an error message, and the delegation rules to the other 2 agents, to the sub-agents I will show you, is if the user gives here a simple greeting, says, hi, hello, delegate then to the greeting agent, and we will have a look what the greeting agent does. And if the user says, ciao, bye-bye, see you, then you delegate here to the farewell agent. Handle your weather requests yourself using get weather. For other queries, state clearly if you cannot handle them. So, simple instruction. Now the tool, we have now the get weather tool that we just defined here, the get weather, access to a database or whatever. And then let's have sub-agents. And we have a greeting agent and a farewell agent. Now, this is just a simple demo, but you know what? The greeting agent can do a lot of things and the farewell agent can do a lot of things. The greeting agent could clear your data, could check it's in the right format. The farewell agent could just check and, round here your search result or double check with another weather service or whatever. You get the idea. Here we have our agent. So we have here Anthropic Claude, for example. The name is the greeting agents. The instructions are now, hey, you are not a greeting agent. Your only task is to provide a friendly greeting to the user. Do not engage in any other conversation or task. So very simplified. It's just the first demo. And the description handles simple greeting and hellos. But you need a clear description of the capability that this system is doing. Now, you get it. The farewell agent is the same. You are the farewell agent. Your only task is to write a polite goodbye. This is it. Or we can build here with tools here much more complex system. So this is the first agent that has tool use and sub-agent. And this is all the code that you need. I think it's okay for a beginner if you say, this is it. What else? Let's have a look here at a complete system. So I just trying to make sense how this is now integrating into everything else that we know. So we have here our agent framework. And now today by Google, we have the new agent development kit. Isn't this great? But of course we have others. No? You know that, years ago, LangChain or LangGraph, Llama Index or Crew.ai, whatever you do, or other Python frameworks, there are also other agent frameworks. And the nice thing that Google has done now says, okay, we learned from all the mistakes. We build now our very latest one to the best of our knowledge. And you know what? We want that our new system is compatible with all the other systems on the market. So what they develop is an agent-to-agent protocol. They make it an open source protocol. So it's open source for you, for me. It's beautiful. And now we have an absolute compatibility. We have tools, built-in tools that Google provides to you, like a Google search. This is beautiful. You can build your custom tools. You have your ecosystem tools. You have your MCP tools, absolutely compatible. You have other OpenAPI tools. You have models for all the Gemini models, and then everything that is hosted here also on Vertex AI. You have your fine-tuned models, your specific models that you can bring up and then run your agents with your fine-tuned or reinforced learning models, whatever you have. And then you have the agent engine, And as you see, Here we talked then about managed session, about memory structures. This is a little bit more complicated. And then, yeah, you can bring it out to the world. You can deploy it, I don't know, 3, 4 continents if you want. You can scale it globally. But I just want to understand here the basic part here. So this is what I'm going to focus now on. Great. Yeah. Agent-to-agent protocol, introducing it, connecting agent across your enterprise ecosystem. So the idea is you are working here for a company, and the company already has implemented something. Let's say it has implemented a LangGraph implementation. Some other departments in the company use Crew.ai here for their agent-to-agent interaction. And now you have this new Google ADK, and now you say, you know what, if I build something new, I can use the old stuff. If it's working, don't touch it here for the first time. Just make it compatible. And this is our open agent-to-agent protocol. It enables agents across different ecosystems to communicate with each other. They said, of course, it's Google say, okay, let's have some partners. So you are from Accenture, Deloitte, Cohere, Infosys, Afric, McKinsey, here MongoDB, Neo4j, whatever you know is here, and LangChain and so on. So they built here a compatible open source protocol. Yes, of course, currently there is a little bit of a hype of a model context protocol. I have a specific video on this. So of course it supports it, and it has more than 100 pre-built connectors and so on. So independent where you are seamlessly connected to your agents. You already have in your company frameworks like LangGraph or tool calls from diverse sources, MCP, LangGraph, application integration, or any OpenAPI endpoints, plus more. So great. So we know the system we are looking now, I'm looking now here, is compatible with the rest. What else? What else is there to develop? Yeah, you have the garden and everything. Agent development kit, the agent engine, we talked about this, the agent-to-agent protocol, we talked about this, 50+ industry leader. It is compatible with MCP. We have everything that Google offers. Well, what a coincidence. And yeah, you have here the live keynotes. Watch now. I haven't watched it yet. I just want to see here the manual. I learned from manual here. If I have my first look, and I get a feeling, I get a first touch on this system. So let's have a look. Agent Development Kit. We have Quickstart tutorial, some sample agents are prepared for you, the complete API reference. So I would say let's jump in and let's have a look. So what we have. ADK makes it easy to get started with simple agent powered by Gemini models and AI tools already predefined for you. Isn't this nice? But you can go fully crazy with complex agent architectures. You can build your own agent, whatever you like. Flexible orchestration, nice. So we have workflow agents, sequential, parallel, and loop workflow agents. We're going to have a look at this. We have multi-agent architecture. This is really important that you can build multi-agent system. You already have with Google a rich tool ecosystem. You can use everything plus third-party libraries, LangChain, Crew.ai, and everything else. It is deployment ready, and you have all the global compute infrastructure. By Google, you have built-in evaluation routines that Google provides for you. Responsible agent. Oh yeah, I've seen there are some safety guidelines you can integrate here. My goodness, they really put some thinking into this. Okay, let's say Quickstart. Let's have a look at a Quickstart. Let's make it maybe a little bit bigger so you can read it. Yeah, that's better. So here we go. Install ADK, beautiful. So you are either macOS, Linux, Windows, or whatever. Pip install Google ADK, create here the project, create a folder, create here another folder, create here the init file. Look at this, create the agent.py file, copy this into the agent.py. Okay. Google ADK agent, import agent. Here we have our get weather example now, beautiful. Now for multiple city, New York, error, beautiful. Define the current time. Okay, world time, nice. New York, beautiful. Time zone. Then we have here our root agent. So let's look at this. So we have now defined our ADK agent, and giving here the notation, we have a name, we have a Gemini model, we have a description that we know what this is doing, answer question about the time and weather in a city, and the instruction says, hey, I can answer your question about the time and weather in a city. And then the tools, we have now tools, the get weather tool and the get current time tool. Get current time is here, and the get weather tool is here. Beautiful. So you see, nice and easy. We have our environment file, beauty. We have here the code, and as you see, we have the user query. Then we have our agent. The agent decides what to do, given now here the content of the user query, decides either to call here the weather in a city or the current time, returns the result. The agent processes here the response from this and provides answer to the user. Couldn't be easier, no? Set up the model. Google AI Studio. This is nice. Or you go with a Vertex AI. Beautiful. They give you the code. Of course, you have your API keys and then you just run your agents. They give you 3 options here. The ADK web, the terminal, okay, and the server. Okay, so I think it's beautiful. Yes, you have more example prompts. Congratulations. Next step. We go next step. So this was this quick start? Yeah, this was the quick start. Streaming, yeah, you can do the streaming. Beautiful. Tutorial. Let's start with the tutorial. Your first agent, multi-modal, building an agent team, delegation, adding memory. Now we add memory, personalization, and a session state. This is not important. Adding safety, the guardrails. Here, more adding safety tool for the guardrails, and your team is ready. Wow, this will be something. Okay, so let's dive deeper and construct a more sophisticated multi-agent system. This takes your skill to the next level. I hope I'm intelligent enough. So what we do, we leverage now different AI models, Gemini, GPT, or Claude, designing specialized sub-agent for very specific tasks, enable an intelligent delegation between our agent. We give the agent memory using a persistent session state. This is now important because we want they are a little bit more intelligent and have its own memory, and implement some crucial safety guidelines, guardrails, callbacks, and everything. So, wow, this is the first example. Let's go. What is ADK again? ADK is a Python framework designed to streamline the development of the application powered by LLMs, creating agents that can reason, plan, utilize tools, interact dynamically with users, and collaborate effectively within a team. Yes. Prerequisite, Python programming, no idea. Familiar with LLMs, no idea. API keys, no, I'm broke. Rebuild, let's dive in. Beautiful, your first agent. Basic weather outlook. So tools, we already had tools. What are tools? Docstrings are crucial. Yeah, the agent LLM relies heavily on the functions docstring to understand what the tool does, when to use it, what argument it requires, or what information to return. And here you have your best practice example. Isn't that beautiful? Get weather. City returns a dictionary, returns here the weather information, status key, so if success, if error, best practice, log tool execution, mark the weather data, best practice, handle potential errors, and then we just tool usage. Now we have our tool defined, built, we define now the agent. ADK, beautiful. The name, as I told you, a model, beautiful, a description, an instruction and detailed guidance for the LLM to know on how to behave, its persona, the goals, and specifically how and when to utilize this assigned tool. And the tool itself, a list containing the actual Python tool function the agent is allowed to use, like the function getWeather. Best practice, and we have now a complete best practice model for the agent. So our agent model is our Gemini, beautiful, and then we go here with agent from ADK. We have a name, we have here the Gemini, we have a description, provide weather information for specific cities. And now look, now we have a much nicer instruction. You are a helpful weather assistant. Your primary goal is to provide current weather reports. Great. When a user asks for the weather in a specific city, you must use the get weather tool to find this information. Analyze the tool response. If the status is error, inform the user politely about the error message. If the status is success, present the weather report clearly and concisely to the user. Only use the tool when a city is mentioned for a weather request. This is a single tool, and here we go. Yeah, now comes something interesting. This runner, this is something that we already know. Maybe you are familiar more than I am. So to manage now here the conversation and execute the agent, Google defines now two components. The first is a session service. This is self-explaining, I think, responsible for managing the conversation history and the state for different users and different sessions. And here we have the in-memory session service is a simple implementation that stores everything in memory, suitable for testing and simple application. It keeps track of the messages exchanged. We'll have a look at this here in step 4. We are still at step 1. And the runner. The runner is our main engine that orchestrates here the interaction flow. Takes the user input, routes it to the appropriate agent, manages calls to the LLM and tools based on the agent logic, handles the session updates via the session service. We'll show you this, and yields events representing the process of the interaction. Events, we're going to talk about events in a second. So, perfect. Here, session management, in-memory session service. Define, API, user ID, session ID. Create a specific session when the conversation will happen. So we have here, create the session, user ID, session ID. And here we have our runner. The runner orchestrates now the agent execution loop. We have the agent defined, we have the app defined, we have the session service defined, the session manager is online. Great. Interact now with the thing. Beautiful. Define an asynchronic helper function, call agent asynchronic, that takes here the user query string, packages it into the ADK content format, calls the runner asynchronic, providing the user session context and the new message, iterates through the events yielded by the runner. Events represent steps in the agent execution. Everything that you know about tool call, to results received, intermediate LLM sorts, final response, identifies and prints the final event using event.isFinalResponse. Why asynchronous? Well, that's clear. Run the conversation. Let's test our setup here, and you have here the code for run the conversation. Call the agent asynchronically. Beautiful expected output. Congratulations. First step. Second step. Going multimodal. Yippee, let's do this here. Some models need some specific task, coding, reasoning, or creative writing. Different models have maybe different price point, capabilities, redundancy. Learn how to configure an agent to use models from providers like OpenAI, the GPT model, or Anthropic, the Claude model, using here the light LLM wrapper. Create new instances, import. Okay, define the agent of different models. In the wrapper, we know how to do this, best practice. Claude Sonnet, beautiful error handling. Yeah. So agent using GPT-4. Here we go. Weather agent GPT. Agent is now GPT-4. Description, provide service, you're helpful, whatever. Tool, the get weather, print. And here the runner GPT. Runner, weather agent GPT, name, app, session. Yep. Agent using Claude Sonnet. Okay. Yeah, I think it's clear what's happening. Interact with multi-modal agents. Okay, since each agent now has its own runner instance, we need a way to direct our queries to the correct runner. Okay. Let's create a slightly modified interaction function call specific agent async that accepts the runner instance as an argument. Okay, we understand. Yep. Get it. Beautiful. Code example, usage, testing here the GPT agent, testing here the Claude agent, multimodal conversation, expected output. Great. Each agent successfully receives the query. Its agent correctly identifies the need to use the getWeather tool. Yep, building an agent team. We're at step 3. Delegations. Agent team, creating multiple specialized, hyper-specialized agents, each designed for a specific capability only. One for the weather, one for the greetings, one for the calculations. Hey, we've seen this, okay? We designate here the master, the root agent, the orchestrator, okay? That receives here the initial human user request and enabling the root agent to delegate a request to the most appropriate specialized sub-agent. We had a very easy example, but now we can build it much more complicated. Modularity, specialization, scalability, efficiency. Define simple tools, create 2 new specialized sub-agents, update the weather agent, configure the root agent with sub-agent, automatic delegation, define the tools for the sub-agents. Okay, yeah, think we get it. Define now the sub-agents. Best practice, sub-agent description field should accurately and concisely summarize the best capabilities, best practice. Here, beautiful code example. Farewell agent. Say goodbye, tool description, okay. Define the root agent with sub-agent. I think we know this already, yeah? Best practice, okay, here you have everything. The runner root, the runner, the agent, API name, session service, beautiful. Interact now with the team. User query, hello there, goes to the runner root. The root agent receives the query. LLM analyzes the query and description of its sub-agent, and it decides the query matches here the greeting agent description. Therefore, the root agent delegates to the greeting agent. Now the greeting agent processes the query, calls its say hello tool, and generates the final response. Similar delegations happen to the farewell query, where the query is not delegated and handled directly by the root query using getWeather. Expected output, I think that's clear. Farewell. Now this is now interesting, adding memory and personalization with the session state. Now we get a little bit more, we give more intelligence here to our agents. So ADK provides this to the session state. What is a session state? Real nice explained, Python dictionary. Tied to specific user session, user ID, session ID. It persists information across multiple conversation terms within that single session. And the agent and the tools can read from and write to this state, allowing them to remember all the details, adapt the behavior, and personalize the responses. Great. This is what we want. We want to have here an agent with a session here where we can write to that has here the complete conversation terms that understand what happened. The agent interact now with the state. Primary method here, tool context. Tools can accept a tool context object. The object gives direct access to the session state via the tool context.state, allowing tools to read preferences or save results during the execution. And then we have an autosave agent response here, output key. An agent can be configured with an output key, will automatically save the agent's final textual response from a turn into the session state. Okay, sounds simple, sounds okay, we can do this now. Okay, in this step we will enhance the weatherbot with our in-memory session service to demonstrate state in isolation. Okay, initialize session state with the user preference, create a state-aware version of the weather tool, update the root agent using the stateful tool, running a conversation, output, okay. Initialize new session service. I think you get the main idea. We create a new session service here. In-memory session service. Define IDs, initial state, create the session, provide the initial state. State initial, 0, print, verify the initial state was set up correctly. Create now a state-aware weather tool. Its key feature is accepting the tool context, which allows it to access the tool context state. It will read the user preference, temperature unit, and format the temperature accordingly. Key concept. This object is the bridge, allowing your tool logic to interact with the session context, including reading and writing state variables. ADK injects it automatically if defined as the last parameter for your tool function. Okay. I see. Okay. redefine sub-agent and update the root agent. To ensure this step is self-contained and builds correctly, we first redefine the greet agent and the farewell agent exactly as in step 3. Then we define our root agent as a stateful one. Last weather report is saved here for our information. Yeah, interact, personalize, expected output, reviewing. Step 5. Safety. Guardrails with callback, before model callback. Okay, I just jump over this. Step 6. Adding safety, tool augment guardrail before tool callback. Beautiful. Then we say conclusion, your agent team is ready. What have we accomplished? You started a fundamental agent equipped with a single tool, explored your ADK's multi-modal flexibility, using the same core logic on different LLMs like Gemini, GPT-4, and Claude. You embraced the modularity by creating specialized sub-agent and enabling an automatic delegation from the root agent. You gave your agent memory using the session state, allowing them to remember the user preferences and all the past interactions. You implemented crucial safety guardrails using both your before model callback and before tool callback. And now we have it. Agent and tools run in session services, delegation, session state, callbacks. Beautiful. Where to go next? More complex state, redefine advanced callbacks, error handlings. Beautiful. Happy building. Nice. Absolutely nice. And you think this is it? And no, we just started here. Because this was just a tutorial. Sample agents. Okay, 17 hours ago. Sample agents is a functional starting point for a foundational agent designed for common application scenarios. It comes with pre-packaged with core logic relevant to specific user cases. You know how to install this. Let's go to the agent 17 hours ago. Yes, it's brand new. We have RAG, customer service, data science, LLM auditor, personalized shopping, data science. Now, let's go to data science with multiple agents. Multi-agent tools, agent tools, session memory, and the RAG implementation by Google. Beautiful. Key features, multi-agent architecture. Let's make this maybe a little bit bigger that you can read it. Then we have a database interaction, applies a database agent to interact. Yeah, of course, BigQuery using natural language queries. Then we have the data science, includes a data science agent that transform data analysis and visualization using Python. Then we have a machine learning agent that leverages the BigQuery machine learning for training, supports the use of a code interpreter for Vertex AI. Then we have a web GUI, a test and setup and installation. And you have everything running the agent, explaining the agent, running the evaluation. I think everything is here for you. Isn't this nice? Data science, deployment, yeah. Sub-agents. Analytics. Have a look. Data science. Generate and use code interpreter, prompt, Gemini Flash, Vertex AI code executor. Okay, I have to have a deep dive. This is a little bit too much for me right now. What else do we have? Yeah, everything else. What else? Oh, yeah. So let's go back. This were the agents. Now let's look at the tools. What is a tool? Tool represents a specific capability provided to an agent, enabling it to perform actions and interact with the world beyond its core text generation and reasoning abilities. Effective use of tools, how agent use tools, reasoning, selection, invocation, observation, finalization. Think of the tools as a specialized toolkit that the agent's intelligent core, the LLM, can access and utilize as needed on complex tasks. Tool types, example, tool context state management. Yeah, tool context state management. Key pieces of information, read and modify the current session state, influence the agent's subsequent action after the tool runs, unique identifier assigned by the framework to the specific invocation of the tool. Okay, I have to go through this step by step. This is a little bit too much for me right now. Example. Okay, function tool. There's the runner, there's an in-memory session service, there are types defined. Tool 1, get weather report. Tool 2, analyze the sentiment of the text given. Beautiful. Then we have an agent. Instruction. Tools are weather tool and the sentiment tool. The session service. Session, create session, runner. Agent, weather sentiment app name, session ID. Agent interaction, call the agent. Runner.run, okay, this is the event, and for all the events in the events, final response, weather in London, tool context. Okay, looks absolutely fascinating. I have to have a closer look. Built-in tools, third-party tools, Google Cloud tools, MCP tools, OpenAPI tools. Everything is there waiting for you. We go on to deploy. No, session in memory. Oh yeah, I have to have a look at this. Why context matters. I'll explain here everything. Beautiful. What's next? Session, understand its structure. State, how to effectively read, write, and manage session-specific data. Session service, choosing the right storage backend for your session. Memory service. Great. Gee, this will take me hours. Session and memory. Artifacts, callbacks. Runtime. Runtime could be interesting. Now what else? Events, context, evaluate, guides. Guides. What do we have with guides? Responsible agents. Oh, wow. Okay, yeah. Okay, we have responsible agents. I believe you. Runtime. Let's have a look at runtime. The ADK runtime is the underlying agent that powers your agent application during the user interaction. It is the system that takes your defined agent, tools, and callbacks and orchestrates their execution or response to the user input, managing the flow of information, the state changes, and the interaction with external services like LLM or storage. Think of the runtime as the engine of your agentic application. You define the parts, the agent, the tools, and the runtime handles how they connect and run together to fulfill a user request. And this is done by Google. And you don't have to care at all about it. And I do really like this. Runner, event processor, services, artifacts, storage, execution logic, callbacks. Nice. The heartbeat, the event loop, the inner workings, the runner role. Okay, here we have the details. The conceptual runner loop. This is interesting. Okay, I think for first overview, you see that how I stumble, how I say, wow, I have no idea about this and I have no idea about that. Isn't that beautiful? So here we have it. Today, the new agent development kit by Google here, how to build your agent, multiple agent fast. I think today is the perfect time to learn about agents if you're not already familiar with this. If you know about multiple agent frameworks, you will find this so easy to understand because it builds upon all the older system. It learns about the mistakes. It has now the optimized version. And sometimes it makes sense to wait a little bit before you really jump into a topic like agent building and agent interaction, how you design your own tools for your own agents, how you deploy them, how you have your safeguards implemented. So why not start today? I guess I have to use my time today to learn much more about this. And I hope you enjoyed it. Hey, why not subscribe and you will get another video real soon.